Hi guys, Mr. Sonnenberg here. Today we're going to be talking about making use of stress. So this is for Science 7 students studying structures and forces, topic 5 in your textbook. And one important point throughout this is we need to know the materials fail when external forces are applied to them. So this can be very useful for us understanding that when we apply forces, that structures will fail and can fail. So we're going to talk about the different types of structural failures. Now, when we discuss this, we're going to talk about a few things. We're going to talk about one, how we can use structural failures as useful information to us, and maybe we can use them as for safety reasons, or we can just use these different forces to make our life easier, to create better products and stuff. So the first one is buckling. So how can we use buckling to our advantage, maybe for safety? Well, the example I'm going to use, I have two examples. One is going to be a bumper and the other is going to be a blade of grass. Now this bumper here individually, before it's put on a vehicle, if we were to look at the side view over here, the side view is actually going to look like this. Okay, and it's going to be somewhat hollow. Now this bumper's job is to take the force in a collision. So this white car has propelled itself into this SUV. Now what's happening is this bumper is going to, which used to have a shape that looked like this, now is caved in and it has buckled inwards. Now what this is doing is it's absorbing force. Okay, so it's going to absorb force of the collision and then hopefully keep the occupant safe inside the vehicle. But the metal is going to fail on that bumper and it's going to absorb that force. So it's actually quite interesting that we think of things like this. Now, the second example I have is the blade of grass down below. And this blade of grass, the reason I say is ball fields are, the outfield's primarily made of grass. So you see these two athletes or the baseball players making fantastic diving catches. Well, when they land, if they were to land on a hard surface that didn't buckle, then they would find it would hurt a heck of a lot more, especially if you're jumping on shale or such. But this grass has a little bit of give and it actually absorbs the impact of the force when the players land. And so what happens is this grass, okay, we have blades of grass. Actually, I'll draw it down here for you guys. We have these blades of grass, and I'll draw it in green. Okay, they stand up, and I'll just draw a short version. So when this player lands, the grass is going to buckle downwards. Okay, it's going to buckle. It's not going to stand straight up like pins and needles. It's going to buckle down. Okay, so that's one way. So we use grass on ball fields as it actually helps out with absorbing the force. Now, the second is shear. We have shear forces, but how do we use shear forces to our advantage? Well, one way we use it is we use shear pins, and I have a picture of a shear pin right here in this individual's hand. And so we use it on the propeller, which is this component of an outboard engine or motor for a boat. And so in that propeller, there's the shear pin hole right here, and we're going to put a shear pin through. So now what's going to happen is this shear pin, if we get caught in the weeds down below, if that prop down here gets caught in weeds, then it's going to entangle. But what's going to happen to this pin is it's going to break. And that pin breaks, and what's going to do is it's going to disengage this component with the actual motor up here. So it's not going to be spinning anymore. It's going to disengage so that we can get it out, because if it continued, the more the boat would be trying to push away, the weeds would be holding it back or whatever that's entangling it, and then we could potentially just tear the motor right off the boat, cause structural damage to the boat, cause severe damage to the motor, and we would have a lot bigger problems. The next example I have is the clutch in an automatic transition or transmission in a vehicle. And so we have to take account, we use shear forces here, and what that it does is it enables parts to slip by one another. And I've just drawn a little diagram here. The clutch is here, okay, and we'll have the clutch pedal, but what's going to happen with the clutch is you can change, well, in automatic transmissions it can happen, or also in manual transmissions where we automatically shift. I put my foot down on the clutch, it disengages the gear I'm in, I move it to a new gear, slowly disengage and press the gas. So These things we use shear forces because parts have to slide by one another and then slide back in. And remember that shear force is that force that goes back and forth on an object. And then we use twisting. So a spinning wheel, for example, I've just drawn a picture of a spinning wheel here, and or not drawn, sorry, added a picture again. There I go, saying I'm drawing things when I'm not. And then a spinning wheel. So what that's actually going to do, it's going to twist cotton and wool together, okay? And it's going to lock those fabrics together, and then we can use them to make clothing or strong fabrics, strong cloth, and use it for many uses. And the second thing we're going to talk about with twisting is controlled twisting. So example is ropes, braids, telecommunication cables, etc. And these things here, what we do is we take the different fibers and we twist them together. And remember, when we twist things, the particles become closer together, the density is increased, and what happens is they become stronger. So we did a lab on that, and we understand those different components. And the last thing doesn't really have to do with how we use metals or use materials per se, or structural failure, but I wanted to add it in here just to touch base on the topic, and it deals with metal fatigue. So sometimes over time or extended use, metals have they'll fail and they'll fatigue, and fatigue means to become weak and then possibly break. So an example is when I was building my house, I had to form and then pour a concrete skirting outside my garage so I can park my vehicles, drive into my garage and such. But what I did was I had to put down the sand base, and then, or the clay gravel mix base. I had to tamp it down. I had to form up the exterior or the outside frame and the walls. And then what I had to do was I had to actually lay rebar down, which was metal, and I had to make square plots to create structurally or concrete that was strong enough to hold vehicles and structurally strong enough. So what I did was I had to tie the rebar together so I had it evenly spaced. I had to put ties on, and they were actually, I'll just draw it really quick. They're almost like little hooks. So they have little here and they go like this. So what my job to do was to twist them together, okay, and then around the rebar. Okay, and I would twist them together like such. But what happened was if I over twisted them, then this part right here would typically, right there, would just break. Okay, and it would break off, and then that's because I over twisted it, right? So we get metal fatigue all the time. So I wanted you guys to be aware that there is metal fatigue as well, and then structures fail. And it's not necessarily something we always use, but metals do fatigue, and sometimes we use those metals. We can use that to our advantage as well. Okay, so it's interesting how we can use some of these things to our advantage, like car bumpers, and we plant grass in ball fields to absorb force, and things such as that, football fields. Okay, so anyways, that is using stresses effectively, and I hope this has helped. Any questions, please ask them in class. Okay, thanks for tuning in, guys. Bye.